Assalamualaikum warahmatullahi wabarakatuh and good morning. In this video, we will learn about determining the area of a region. How to find the area between the curve. First, you need to know how to graph the curves. Next, find the limits of integration. Write the formula and integrate the formula that you write in step 3 from A to B. Now, say we have a curve like this and the limit is from A to B. So to find the area, you can integrate from A until B of the curve with respect to x. Next, if you have a curve below the x-axis within the limit A and B, then to find the area, you need to put an absolute sign or modulus so that you can have a positive area. And for the next example over here, if you have an upper curve and lower curve to the x-axis, to find the area, for the upper curve, we just integrate as it is from A to B, but from B to C, since the curve is below the x-axis, so you need to put absolute value sign over here. This is because we want to make sure the area is positive. We cannot have negative area. Find the area of region between the curve y and the two x values together with the x-axis. So you need to sketch the graph of y equals to 2x minus x squared. Okay, here we have the x value at 0 and 2. So mark down the two values. Sketch the graph. And here is the shaded region. As you can see, the curve is bounded by the line here. Okay, x equals to 0, x equals to 2. So it starts from 0 until 2. And here is the x-axis. Next, we want to find the area. Okay, we will shade the region and we now ready to write down the formula for area. So the limit of integration will be from 0 until 2, and the function will just be 2x minus x squared. And then we just integrate as it is, applying the definite integral rules, and we will get the result. For the next example, we want to find the area bounded by cos x and x-axis from 0 until x equals to pi over 2. So first of all, you need to sketch the graph of cos. Okay, actually the graph of cos is like this, from here until here, but we want to find the graph or draw the graph from x equals to 0 until pi over 2. Well, after we draw this graph, okay, we need to find the y-axis. I don't think we need to find it because we just want to integrate with respect to x. So if we want to integrate with respect to x, we just need the x coordinates, which are from 0 until pi over 2, and then just insert the function cos x. Integrate cos, we will get sine, and then just substitute the limit to get the answer. Next is to find the area, but now we have the curve and the y-axis. Like in the first example, as you can see, we are dealing with the limit on the y-axis. So to find the area, it is from C until D, and the subject will be x, so that the function is all in terms of y. I will show you in the example later. Same goes to the example over here. But now the curve is on the left-hand side. So we need to put an absolute sign so that we get positive area. And as for the last example, we have curve shaded on the right side and on the left side of the y-axis. So for the right-hand side, we don't have to put any absolute value sign, okay, which is from B to C over here. There's no absolute sign. While for the left hand side over here, we have an absolute sign because we want to make sure the area is positive. Okay. Find the area of the region bounded by the curve 2x cubed, line y equals to 2, y equals to 5, and the y-axis. So in this case, you know you will integrate with respect to y. But before that, let us sketch the graph and mark down y equals to 2 and y equals to 5. So here is the y-axis and the shaded region. So now you are ready to integrate from 2 until 5, and the function inside cannot be 2x cubed. But you need to make sure the function inside here is y. So we need to make x as the subject. From here, we bring 2 to the other side and we will have power 1 over 3. So y over 2 power 1 over 3. Now everything is all in terms of y. Then we are ready to integrate. Let us look at the next example over here. We have area between two curves. And now we are dealing or we are going to find with respect to x. Just now, the two examples in the previous slides are area between the x-axis or area between the y-axis. But now we are dealing with area between two curves. Now, to find the area between two curves, if we are going to calculate with respect to x, we will take the upper graph or upper function and then minus the lower function. As you can see, say the upper function is f, the lower function is g. So to find the area, okay, we will integrate from a until b. Upper function is fx and then the lower function is gx. So we need to subtract these two. So in exam or in UPS or in your assignment, okay, you will need to start with this line over here in the second one. Fg minus Gx. Now let's take a look at this example. Find the area in the first quadrant bounded by y equals to cos 2x. Okay, so this is y equals to cos 2x. Y equals to sine x. Here is y equals to sine x and the y-axis over here. So clearly, the shaded region will be over here. So first of all, we need to find the point of intersection between cos 2x and sine x. Okay, because we need to know the value of point between the two curves over here. So to find the point of intersection, we will just perform simultaneous equation. But in this case, we need to change the form into using double angle formula. Okay. So we have 1 minus 2 sine squared x. And then we can group all of them in one side and let it equal to 0. Factorize. And we will get two solutions. Hence, the x value will be pi over 6 and negative pi over 2. Sorry, 3 pi over 2. Okay, so we ignore this value because we just deal with the first quadrant. Okay, now we are only looking at the first quadrant. So now I have pi over 6. So to find the area of shaded region, okay, if I take all of this under the function cos 2x, I minus with the region below y equals to sine x, I will get this region. Okay, let me repeat again. If you take all of this region and then I minus with this, I will get the required one over here. So my formula will be cos 2x minus sine x. Okay, cos 2x minus sine x. The limit are all the same, and hence I can write out like this straight away. So in your individual assignment, you can straight away write down like this. No need to write down one by one based on the shaded region. X, to integrate, we can directly integrate because all of them are of power 1. So cos integrate, we will get sine. And sine, we will get negative cos. That's why the sign over here is changed to positive. Next, we need to substitute the limit, pi over 6, and we will get the answer. Make sure before you substitute the limit, you change your calculator into radian mode. Next, we will look at an example to find the area between two curves, but now the integration will be with respect to y. Say I have a function over here, okay, between a and b. So to find the integral, I will start from the right one over here, x2. Okay, and then minus the left one. So we'll start from the right one and then minus the left one over here, as you can see. Okay, let me show you an example. Calculate the area of the region bounded by the x-axis, the curve, and the line. Integrate with respect to y. So first of all, you need to sketch the graph of square root function and linear function on the same axis. So here is the x-axis. Next, we will draw the square root function and the linear function. So where is the shaded region? It is here. Okay, and we want to integrate with respect to y, which means that we need to find the intersection point over here. So we just apply the simultaneous equation. Squaring both sides, we will get the result 4 or 16 for x values, but now we need to find the y values. Okay, so over here it is 4 and 16 on the other side. Okay, 4 or 16. Okay, actually dia dapat 16 tu bila you lukis penuh. Macam ni, lukis penuh. Nanti akan ada satu intersection kat sini. But we only have positive set, so kita hanya lukis separuh lah. Tak perlu lukis penuh. So kita hanya akan ambil jawapan 4 ni lah. Okay, so 4 kat sini. But we need to find the y intersection. So if we try to substitute y inside any of one of the function, we will get 4. Okay, so gantikan 4 kat sini. So jadi 2 kan, 2 kali 2, 4. So kita dah dapat lah intersection point di sini. Okay, again when I repeat, di sini ada 2 jawapan jika awak lukis parabola yang penuh. Tapi memandangkan ini hanyalah square root function dan kita hanya ambil bahagian yang positif, maksudnya kita hanya lukis bahagian atas. So 4 sahajalah diterima, 16 tidak diterima. Okay, so now here we have the y intersection at 4. Okay, so now to find the area, okay, we can see a trapezium over here. And then, if we find the area of trapezium, we need to eliminate this area so that we get the required one. So this small area over here is from 0 until 4 and it is under the curve over here. So 2 third x. Okay, 2 third x. But we are going to integrate with respect to y. So we need to make x as the subject and we will get y over 2 squared. Okay, so be careful before you integrate. Always make sure all of them is in the same variable. Baru you boleh integrate dengan baik lah. Okay, so to find the area of trapezium, it is easy. Just use the formula, okay, 1 over 2. The formula will always start with 1 over 2. And then 12 times 4. Okay, so 4 is the height. 12 is, 4. And then over here, 12. 4 is the height. Okay, and 12 is the base. Where we need to add these two lines. Okay, so the formula is 1 over 2 times the addition between the two parallel lines and multiply with the height. Okay, and then minus the derivative of y over 2 squared above, and we will get the corresponding area. Okay, so here is an exercise and I want you to do this exercise and submit through GC. So thank you. I hope you can try tutorial question. Okay, and I will assign tutorial question in tutorial classes. Okay, so please try this exercise only. Okay, and submit to me. I don't think we have any other exercise. Yeah, only one exercise. Okay, so please submit this exercise through GC in lecture link. Thank you.